Okay, now let's look at example 2. This is when things are going to get a little more complicated and we do need to do a little bit more work. So it says find the limit as x approaches infinity of 2x minus 1. So notice that would be like doing 2, if we were to plug it in. Remember, you can't, so it would be 2 times a very, very large number minus 1 all over a very, very large number plus 1. Well, 2 times infinity is infinity, minus 1 is still infinity. So this is kind of like having an infinity over infinity, and that's another indeterminate form. So just plugging in numbers here, or conceptually thinking about it, wouldn't work. But let me teach you a trick. The trick is you want to divide by the largest power of x. So do you agree this is the same exact thing as the limit as x approaches infinity of, well, the largest power of x is just x, right? So this should be the same thing as 2x over x minus 1 over x, all over x plus 1 over x. Now this is a trick. It's not necessarily in the book, so I don't want you to get too comfortable with this, but it's up to you to think about this, okay? So all I'm doing is dividing every single term by x. Let's see what happens when I do that. The 2x over x is going to simplify, so I'm going to rewrite this as the limit as x goes to infinity. The 2x over x simplifies into a 2. Then I have a minus 1 over x. On bottom, the x over x simplifies to a 1. And then we have plus 1 over x. Well, let's see what happens now. If I'm thinking about the limit as x goes to infinity of each one of these terms, well, the limit as x goes to infinity of 2 is 2. The limit as x goes to infinity of 1 over x, well, this term would go to 0. My denominator would be getting huge, and so 1 over a huge number goes to 0, right? And then on bottom, I'd have 1 plus, well, 1 over x. Again, 1 over x is going to go to 0 because my denominator is getting huge, huge, huge. So this is going to equal 2 minus 0 over 1 plus 0, which is 2 over 1, which is just the number 2. So a nice little trick on that one, when you have something like infinity over infinity, which is an indeterminate form, would be to divide each and every term by the highest power of x. Really cool trick. Will help you out there. I'm actually going to teach you another trick here momentarily that's going to give you a better idea of what to do on those ones. But nice little trick there for you. Again, if you weren't comfortable with this, what you could have always done is you can always, I'm never going to get mad at you for doing your chart. Just be comfortable with what you're doing. Plug in 1, plug in 10, plug in 100, because we're getting bigger and bigger, right? See what's happening to those y values, and you should see them approaching a y value of 2. Okay? It says, the result from example 2 can be seen as a horizontal asymptote of y equals 2 in the graph of f of x below. So what did we just figure out? We just figured out as we go to the right, it approaches the y value 2. So this y equals 2 is a horizontal asymptote. So as we went to the right, it approached 2, so we know this is a horizontal asymptote, okay? When you encounter an indeterminate form, such as the one in example 2, so what they're talking about here is when we saw infinity over infinity, okay? You should divide the numerator and denominator by the highest power of x in the denominator. So that's what they're telling you to do. Anytime you have infinity over infinity, always divide by the highest power of x in the denominator. Actually works if you do it for the numerator as well. Or sorry, not the numerator, of the overall function, but always divide it by the highest power of x in the denominator. Okay? So what's that going to do us? We're going to look at different examples of when we would have infinity over infinity. Well, if you want, go ahead and download this little file right here. Open that Wolfram CDF player. Again, all of this is free, and you can start playing with it. Or you could just graph all of these in Desmos.com, or just pay attention to the algebra right here. So it says find each limit. The limit as x approaches infinity of 2x plus 5 over 3x squared plus 1. Well, I'm going to think about this real quick. 2 times infinity plus 5 would still be infinity, right? So that gets infinitely large. Bigger and bigger numbers. 3 times infinity squared plus 1 would also be infinity. So I have an infinity over infinity here, which is an indeterminate form. So that means I need to do something else. Well, what they just said to do is always divide by the highest power of x in the denominator. Well, I have 2x plus 5 over 3x squared plus 1. The highest power of x in the denominator is x squared. So what I'm going to do is rewrite this. The limit as x goes to infinity. I have a 2x plus 5 on top. I'm going to leave some room here. On bottom, I have a 3x squared plus 1. What I'm going to do is divide each and every term. Because I'm doing it on top and bottom, I can do this. I'm going to divide each and every term by x squared, the highest power of x in the denominator. I'm going to go ahead and simplify each term. So 2x over x squared would simplify into a 2 over x. 2 over x. Getting ahead of myself here. 5 over x squared, that stays the same. 3x squared over x squared would simplify to a 3. And then we have a 1 over x squared, that stays the same. So this is the same thing as the limit as x approaches infinity of the first term simplified to 2 over x. Then I have a 5 over x squared. On bottom, I had a 3 plus a 1 over x squared. Okay, so let's see what happens here when we do this one. Looks to me like on top, what happens as x goes to infinity? Well, 2 over x would go to a 0. 5 over x squared, again, infinity on bottom, so that goes towards 0. 3 just goes to a 3, and 1 over x squared would also go to a 0. So that would be going to 0 plus 0, each one of those terms, over 3 plus 0. Notice I'm not writing the limit anymore because I've actually evaluated the limit. So on top I have a 0, on bottom I have a 3, and that's not undefined. That is the number 0. So what did 2x plus 5 all over 3x squared plus 1 go to as x went to infinity? And the answer is 0. So what would that tell me? That would tell me y equals 0 is a horizontal asymptote. But that's not what the question asked. It just wanted the limit. But I'm getting you to think big picture. Why do we care about that? Well, we were able to now find a horizontal asymptote of a function without having to look at the graph of the function at all. Really cool stuff.